Systems of equations can be used to solve real life problems, and we're going to be taking a look at this one that has to do with two burning candles. So we've got two candles that are burning. We've got a taller 10-inch candle, and we have a shorter 4-inch candle. The 10-inch candle burns at a rate of 2 inches per hour, and the 4-inch candle burns at a slower rate of a half of inch per hour. We're asked after how many hours will the candles be the same height. So because that 10-inch candle, even though it's taller, it's burning at a faster rate, it's going to eventually catch up to the 4-inch candle, and we want to know after how long will that happen. So let's take a look. Okay, we can write a linear equation that describes the burn rate for each one of the candles. And then we can take those equations and graph them on a coordinate plane to see after how many hours they are going to be the same height. So our question is, after how many hours will they be the same height? So we're going to be looking down here for hours. So let's start off by writing an equation for the 4-inch candle. So we have the 4-inch candle burns at a rate of half of an inch, missing the one there, per hour. Okay, so y is going to be our total height, and the rate at which is burning. Remember, slope is rate. So our slope here is going to be negative half because we're burning, so we're losing candle, so negative 1/2. And then the y-intercept is going to be the start. So at time of 0, the height of that candle is 4 inches right here. So that is my y-intercept there. And then we'll write an equation for the 10-inch candle. So 10-inch candle burns 2 inches per hour. So total height equals, remember the slope is the rate of change, and so that's minus 2 inches per hour. X is hours, C on the x-axis. And then the y-intercept here is going to be a positive 10 because we're starting way up here at 10 inches tall for that candle. Okay, so let's graph the 4-inch candle. We have a burn rate of half inch per hour, so negative 1/2. So instead of rising 1 and running 2 to the left, I'm going to fall 1 and 2 to the right, fall 1, 2 to the right, and I'm going to keep that going here. And we can see that even though we start at a 4-inch candle, the candle is going to be burnt out here at 8 hours. Okay, we can see that negative 1/2 slope, candle's gone after 8 hours. Okay, then we got the 10-inch candle way up here, and the slope is negative 2. So 2 over 1. Instead of rising 2 and running 1 to the left, I'm going to fall 2, 1 to the right, fall 2, 1 to the right. See how it's burning faster? The slope is much steeper. There we go. And do you see how after 5 hours, the candle will be completely burnt out? It will be at a height of 0 after 5 hours. Okay, so we can see that where they intersect here, this is when they're going to be the same height. And the point of intersection is here at 4, 2. Now let's look at what that means. The 4 is on the x-axis, right? That is representing hours. And the 2 is on the y-axis. That's representing height in inches. So after 4 hours, both candles will be at a height of 2 inches. So after how many hours will the candles be the same height? 4 hours, and they will be the same height. What height? 2 inches tall. And so a system of linear equations can be used to solve a real life problem when you can write two linear equations for the situation. Thank you for joining me.